Have you ever wondered how remote sensing works? Remote sensing is a fascinating technology that gathers information about our Earth's surface from afar, be it from satellites in space or aircraft hovering above. This isn't just some high-tech wizardry. It's a vital instrument in fields like geography and environmental studies, helping us map terrains, track climate change, and much more. Now that you have a basic understanding of what remote sensing is, let's delve into how it works. So, how does remote sensing work? It all starts with a source of energy. The energy we're talking about here isn't the kind you get from a cup of coffee in the morning, but rather something much more powerful. Typically, this energy comes from the sun, our own personal star. Alternatively, it could be an electromagnetic radiation or EMR source located right on the platform of the remote sensing device. Now imagine this energy as a marathon runner, and its race route is from the source to the object that we want to study. Along the way, this energy, much like our marathon runner, faces obstacles. This part of the journey involves the energy being absorbed and scattered as it travels through the Earth's atmosphere. It's a bit like our marathon runner dodging water cups and cheering crowds. Once the energy reaches the object, it interacts with the Earth's surface. This interaction varies depending on the characteristics of the object and the type of energy. It's similar to how a runner's pace might change when moving from pavement to a sandy beach. Next, the energy embarks on the return journey, transmitting from the object back to the sensor. It's like our marathon runner making a strong finish and crossing the finish line. The sensor is the race official, registering the runner's time. In remote sensing, the sensor records the energy. It could be a photographic sensor capturing images like a camera, or a non-photographic sensor measuring thermal or radar signals, for instance. Once the energy is recorded, it's then transmitted to a ground station. This is the equivalent of our marathon runner's time being posted on a leaderboard. The ground station is where the real magic happens, but we'll leave that for the next scene. So, in a nutshell, remote sensing is a marathon where energy travels from a source, interacts with an object, and is then recorded by a sensor. It's a fascinating process, and we're only scratching the surface here. But remember, once the energy is recorded, it's then transmitted to a ground station. And that's where we'll pick up next time. What happens after the energy is transmitted to the ground station? This is where data processing and analysis come in. The recorded information, brimming with potential insights about our Earth, is received at the ground station. Here begins the process of transformation. This raw data is meticulously processed and converted into a more understandable form, either a digital or hard copy image. But the journey doesn't end here. This image, though visually appealing, is like a cryptic puzzle waiting to be solved. And so begins the process of data analysis. Scientists, like skilled code breakers, extract valuable information from these images. They might uncover patterns in vegetation growth, monitor shifts in ocean currents, or even predict the trajectory of a hurricane. Through this rigorous process, remote sensing data morphs from a collection of numbers into a tool for understanding and preserving our planet. And that, in a nutshell, is how remote sensing works. To recap, remote sensing is a complex but fascinating process. It begins with a source of energy, often the sun, which transmits energy to the object on Earth's surface. This energy interacts with the Earth, then transmits back to the sensor, which records it. The recorded information is then sent to a ground station, where it's processed into a digital or hard copy image. Finally, the data is analyzed. Although it might seem complicated, understanding how remote sensing works can be extremely rewarding, especially for those interested in geography and environmental studies. So the next time you look at a satellite image, remember the intricate process behind it.